Lesson 2 on our introduction to Euclidean geometry looks at the study of angles. So we are going to look at the properties of angles and their theorems. Now, before we can understand these theorems, it's very important to understand the following building blocks. Say, for instance, you have a point which usually will use an abbreviation PT for a point. Now, a point will be represented using a letter. For example, if I write the letter A, this means that I'm saying A is a point. When you look at it as a geometric picture, it will be a point like this and we'll write the letter A on it. Now, a point doesn't necessarily have to be the letter A only. This could be any letter. It could be C, it could be a B, it could be a D, it could be an O, or even a Z. Any letter. As long as you write a single letter, then it represents a point like that. Another thing that we have to understand is that if we have a straight line, we will represent it using two letters. So I can write the letter A, B. If we see a letter A, B, or any two letters really, it means that we are actually having a line. So that means here we're going to have a point here, which was going to be an A, and another point here, which is going to be a B. Now, when we say AB, we simply mean that we have a line that moves from A and it goes to B. So when you see any two letters, they represent a line from A to B, just like here I've drawn them on the diagram. Also, this could be any two letters. Sometimes a line is drawn using three letters. So I can draw a line by saying A, B, C. This is to say then that I have point A, then somewhere here I have point B, and somewhere here I have point C. Now when I join all these 3 points, I then have a line that moves from A to C. It moves from A to C. So when you see 3 letters A, B, C, they actually mean or imply a straight line as well. So those are 2 different ways of drawing a straight line. Now, this second part of drawing a straight line is inspired by the fact that we have here a line AB which is produced to C. So what I mean by that is that we extend this line to C here. When I say a line is produced, we have a line AB which is produced to C. I mean that I've extended the line AB to C. To say something is produced means that we have extended that line to C. Very important terminology to understand. You will get that a lot in your question papers. The other thing that we need to understand when we have to look at our theorems here is that sometimes you can have the line AB, which then we have another line here, let's say C, B, C. So I have 2 lines here. I have the line AB and the line BC. Now, when you look at these 2 lines, they actually make an edge here, some form of a corner. And this corner, we call it a vertex. We call this corner here a vertex. That edge, we call it a vertex. Now, when we have a vertex, we can measure an angle on that vertex. So this means we can measure this part here to be an angle, and it is measured in degrees. So here we can actually come up with an angle. So an angle basically is just the space between these 2 lines, the space that is created in a vertex. So here we can measure an angle. A vertex gives us an angle. And the important thing that then catches our attention is that how do we then represent angles? How do we write them down? Well, what we do here, we will then say here, we can write it as angle ABC. So what we're doing here is saying if we start from point A, we go to B and we go to C, we'll create the angle here at B. Do you see here I've used an accent at the top of that letter B to say the angle occurs here on the letter B. That's how we'll write our angle. Alternatively, other people can also just write the letter B and write an accent at the top to simply say here at B, that's where we measure our angle. This accent at the top there, it says that's where we measure our angle. At times, we can have a line that actually say it goes from A, B, C. Then let's say we make another vertex here, we make another edge here. So we have another vertex here or another edge. Now what happens here is that we have two edges. So we will call these two, we will then have a name for these two. It's a plural actually of the word vertex. We will call them vertices. So we will call this vertices. That just means that we have more than one vertex. It's a plural of that word. It is very important to understand this because when we look at our theorems, it will be elements that come in our theorems. Now in theorem 1, it says that the adjacent angles on a straight line are supplementary. Before we go any further, let's fix the language here. When we see the word adjacent, it means next to. So this means here we are saying angles that are next to each other. That's what we simply mean. And the word supplementary would mean that angles that add up to 180 degrees. So if you have angles that when you add them, they give you 180 degrees, we give them the term supplementary. We say they are supplementary. Now, because this is a theorem, it will have two parts to it. The first part will be the A part. And we can see from this statement that the A part, remember, it is the given part, is what we start with. So here we are starting with the fact that we have angles that are on a straight line. We have adjacent angles that are on a straight line. So this is the A part. From here to here is our A part. And when we have such angles on a straight line, we then conclude to say that they are supplementary. It means this part here now, it is the B part. It is our conclusion. Remember the definition of a theorem and the structure of the theorem. It has to have that if A then B part. So our A part here is the fact that we have angles on a straight line, and obviously they must be adjacent next to each other. Then if that's the case, we can conclude that they must add up to 180 degrees. With that, we then often sometimes like to summarize or write the theorem in short. So here in brackets, we're actually writing this whole statement, but in short. Now, when you look at this statement here, this type of an instrument here or a geometric notation here stands for angle. If you see something like this here, it stands for angle. If you put an S at the end, it means angles. So if I read the whole thing here, it reads as follows: angles on a straight line. So whenever you see a statement like this that says angles on a straight line, it is actually a theorem 1. It basically in full means that adjacent angles on a straight line are supplementary. But however, it is important to notice that if I were to write the A part, if I were to take this A part and write it down, Meaning, if I were to write this statement from here to here, which we said is the A part, it will simply be written as angles on a straight line, because that's what we have here. We have angles on a straight line. Obviously, they are adjacent. So we'll write them in that sense, to say angles on a straight line. Now, when you look at the A part, this part here, which is this part of the theorem, and you also look at the short version of the theorem, these two are exactly the same. We write them in exactly the same way. This is to say that the short version of a theorem, this statement here, actually takes the A part of the theorem. So both of them are exactly the same thing. Now, it is important, as I started by looking at the diagrams when we began this lesson, to actually see this statement in a diagram, because oftentimes when we solve problems, they'll come in diagrams. So what we start with here, or what we have, is actually the fact that we have a straight line which we call AOB. So we have a straight line AOB, that's what we start with. And on this straight line, we have a line that comes through like that, and a line that comes through like that as well. Now, these two lines, when they come on this straight line, they then create vertices, meaning they create these edges here, this edge here, and that edge there, and this edge there. Therefore, making these corners here, or these vertices, to be measured as angles, it then means we have angles O1, O2, and O3. We have three angles, but these angles are sitting on a straight line. If we have that as our starting point, if this is what we are given, or what we take as the hypothesis, then we can conclude really to say that angle O1 plus angle O2 plus angle O3, they give us 180 degrees. That is to say they are supplementary. That's the conclusion we can make. So the adjacent angles are supplementary. This is how you would see it on a diagram. Now, if we were to write this down, maybe in problem solving, we would simply say the sum of all these three angles are equals to 180 degrees. However, when you write such a statement, you then have to give a reason to say, why do you say these angles add up to 180 degrees? Well, the reason would be your short version of your theorem, because basically what you're doing here, you are telling us what theorem you have used to make this statement. And the theorem that we used really is the theorem that says angles on a straight line are supplementary, which is this theorem here. And remember, we said that this short version is exactly the same as the given part of the theorem.